Hi, everybody. Hope we had a good lunch. I'm here, I'm from Dell, as she said. I'm going to be talking about Razor today. And besides the Deepak's talk this morning, who's heard of Razor before? Okay. And is anybody actually using Razor right now? Nobody? One, there you go. So this talk will not be very interesting for you, but hopefully the rest of the people will give you some insight as to what's going on there. So let's see. So who am I? Like I said, I work at Dell. I'm working on a newish product called Active System Manager. It's about a year old, and we're using Razor and Puppet. And that was my first. It was a very fast moving project, and my very first introduction to using Puppet, and certainly using Razor. I think at the time Razor was at like 0.10, which might have seemed a little crazy to use that in a project we wanted to ship, but we did, and it's worked out fine. So anyway, so a little more about that particular project. So I'm actually not a very good Puppet guy, so this is a good conference for me to come to. Hopefully I'll pick up some tips. The way we use Puppet is not very traditional. We're using Puppet to configure hardware like storage arrays and switches, things like that in our case do not have Puppet agents on them. So this is like Dell EqualLogic storage arrays, Dell Compellent storage arrays, and the Dell FTOS switches. So for those we're running Puppet, we have Puppet modules that are proxying to the devices and operating through APIs and things like that. So it's primarily, we have like kind of an orchestration engine that just runs, so sorry, back up a little bit. What we're trying to do is actually configure stacks of hardware like racks of equipment. So the case is like, particularly if you buy like a chassis full of blades, you've got 16 blades in there. If you want to get all that set up, you've got to go to each, maybe you can go to the chassis GUI and configure it there, but you've also got to go to the switches and configure all the server-facing ports, and you've got to configure the storage array, configure the storage to talk to the servers, so kind of a pain in the butt, and that's what we're trying to make easier, because we want to sell more hardware because we're Dell. And we do have some support for heterogeneous environments, so like we'll do NetApp provisioning and some Cisco switches, since most people don't have all Dell equipment. But anyway, so for each of these, in the little diagram there, this is like one of our services we provision, and we have a little deployment engine that just goes through, and for each of these things is calling Puppet apply or Puppet device to configure those things. And so we typically configure like a cluster, like a Hyper-V cluster or a VMware cluster. So we connect to the provision the storage, connect to the storage, do the switch provisioning, and all that business. And the good thing is we use Razor to install OSs on the servers. So we use Razor to install ESXi or Windows or Linux, Red Hat or CentOS right now. And that's what I'm here to talk about today is the Razor side of things. And like I said, it's been a really good project, or a really good piece of tool for us to use. So what is Razor? Being a programmer and a geek myself, I was interested to find out what it was running on. And it's a Pixie OS provisioning server. And we'll get to Pixie in a second. And it's basically a web application. It's running on TorqueBox, which is a Red Hat project that's essentially JBoss outfitted to run JRuby code. So you can run Sinatra and Rails apps on it, and you get access to all the JBoss services. I'm from a mainly Java background, so to me that's kind of cool. And obviously it's using JRuby to run on TorqueBox, but essentially it's a Sinatra web app. And Postgres for storage. So Pixie and iPixie. Who knows how Pixie works? Okay, so a lot of people are pretty familiar with Pixie, so that's good. So it's just another Boot option, it's going to be like hard drive, USB, CD, etc. So if you have a server or a VM or another computer that has a Pixie-enabled NIC in it, you'll see the NICs available as boot options. And you just put them in the boot order like you normally would. And then once that boot order is hit, it's going to try to Pixie boot, which uses DHCP to get kind of the information of where to Pixie boot from, and then it uses TFTP to download files. But Pixie itself is really super simple, and it'll only do TFTP, and it's not very flexible or easy to use. So Razer is actually using iPixie to do a little more of the OS installation. So iPixie is an open source boot firmware, and so it's a little more intelligent than the plain Pixie client that might be built into your NIC. And I think you can actually flash NICs with iPixie firmware, but I've never done that. What we do and what Razer does is to basically load the iPixie client through Pixie. So then now you have the iPixie client running, and so now you can do your OS install through iPixie. And the reason we do that is because it's a lot more flexible. It can talk a bunch of protocols like you'd expect, like HTTP. And so you have to be able to do that to talk to Razer, since that's how Razer works. Just a note so if you're using if you're working in a real live network, and you have like a segmented network of VLANs to segment traffic, one thing to note here is that the DHCP traffic from the Pixie client and the iPixie client are always untagged. So you'll have to set that as your Pixie network as your untagged VLAN. For this talk, I think we're going to talk mainly about using it in a virtual environment, so you won't, that's not an issue here. But the Danger Will Robinson slide, if you go through the Puppet Labs Razer walkthrough, they'll warn you about this as well. And the things to note are we're installing operating systems, so you have a good chance of wiping out somebody's hard drive if you don't know what you're doing. Because by default, when a server boots up and Razer sees it, it will install a microkernel on it, which is a simple Linux image to get some inventory data back. And then after that, it's going to actually install the OS if certain conditions are met that we'll get into later. So A, you can wipe out people's machines, and B, you have to have the DHCP server configured to work with Razer. And if you're on your corporate network and you add a DHCP server in, there's probably already one there, you're probably going to blow up the network. So don't do that either. Razer does have a new setting, or I'm not sure what version it came in, but there is a config option called Protect New Nodes. And if you pick that, then it will, by default, it will not try to install an OS on a machine, and you have to take an extra action to go and get the OS installed. So if you are on a network where there might be stuff that you don't control, that might be a good option to use. Okay, so that out of the way. Puppet Labs has a really great walkthrough now on their site. So the Razer docs are definitely improving. They used to not be so great, but there's really good information there now. And they recommend using DNS Mask for initial testing, especially in a virtualized environment. And DNS Mask is actually a really cool, nice little tool if you're just running a small network. It's kind of a Swiss Army knife. It'll do, it acts as a DNS server, a DNS forwarder, so if it doesn't know about a domain name, it'll forward off to a public DNS server. It'll do TFTP, and it's of course also a DHCP server, which is why we're looking at it. And for all the testing that we're doing here, I've just disabled the CentOS firewall and SE Linux. You will have problems with them unless you configure them appropriately. So the shortcut is to just turn them off. And those commands there, the service IP table stop and 740 will turn them off until it's rebooted again. I'm actually not going to, so this is a little snippet of config that goes for DNS Mask. I'm not going to look at that right this second. But basically what this does is add options to the DHCP server so that it has options to the DHCP responses so that the Pixie client can know where to boot off of, where to get the boot images from. On the next page I have, so the more normal choice is probably using the standard Linux DHCP server. This is if you're running a bigger network or something. And this is the config, a sample config from that. Again, accomplishing kind of the same thing the previous slide did, but this little section is actually easier to read, I think. So what I wanted to get into here a little bit is that, let's see here. We have this bit about if the user class is iPixie, then say the file name is bootstrap.ipixie. Otherwise, it's undi-only.kpixie. This second file is a binary. It's the actual iPixie binary. And the first file is a script that iPixie can understand and execute. So what this is doing is saying that if in the iPixie client, when it requests a DHCP response, it includes a client option saying that it's an iPixie client. And so this little bit of code lets basically the server give the initial Pixie client the iPixie binary, and then so it installs that iPixie client and runs it, and then after that, the iPixie client is going to include the iPixie user class and its options that it requests with. And so then after that, it'll get back at Bootstrap, which is just a script file that it can execute. And then the last thing on there is the next server. This is actually the IP, oops, let's do that. This is the IP of the thing that you want to, or the server that has the file. So in this case, we'd expect that using TFTP, I could go to that 172.18.2.100 and download either UNDI only or Bootstrap. So the previous slide had similar stuff, and then you can also do the Windows DHCP server, which we do a lot. And it's pretty much the same thing, except you have a nice GUI. And the main things you're setting is that boot server host name and the file. Okay, so for this, we're going to go through kind of a demo. We'll do like an OS install and some initial Razor setup. And so for this, I used the Puppet Labs or Puppet Enterprise Razor that they have as a tech preview now for 3.7, I think it is. And it's nice and easy if you're using that. You can just classify your node. You get your node checked in with the Puppet Master, and then classify it with this PE Razor module. And that'll do all the work for you. It'll install Postgres, Torquebox, and everything else that you need. Not DHCP or TFTP. Do that separately. You'll also want to install this Razor client, the gem install PE Razor client. That's just a command line tool that you can use to interact with the Razor REST API. And this is just for reference. There's locations on the PE Razor install. The base directory, which is where all the code files are, config file and log file. So I talked about the UNDI only, which is iPixie client, and I talked about the Bootstrap file. So you have to get those installed on your TFTP server. So if you're using DNS Mask, the default location will be var-lib tftp boot. You can download the iPixie binary. Puppet Labs guys have a link to it, and then the second link is to the iPixie site. I have no idea how they do versioning. It's very obscure. So if you go to the iPixie site, I don't know what version you get, or if it matters really. And then the next thing you need is the Bootstrap script. That's actually generated by Razor. So this is an example of one of Razor's REST APIs. By default, it's on port 8080. API, and everything under APIs is REST API for managing it. Microkernel Bootstrap. So this thing just spits out this script file, and you can copy it in as a static file to use later on. The NIC max bit it changes the script a little bit. If you want to boot with more than one NIC, if you want to have more than one NIC enabled, you can bump that up. I'm not really sure why you would want to do that. So pre-flight checklist. So if you're getting all this going, It's not really that complicated, but there are a lot of, you have to have DHCP, TFTP, and Razor all working together nicely. So I'd recommend going through kind of these steps to see what's working, what's not working. For DHCP, you can take just any Linux host, put it on the network, shut the network down and restart it. If it takes a really long time to restart, that's probably DHCP timing out. Otherwise, you should be good. And if you check var log messages, you can see the DHCP request and offer. And you want to make sure that the offer came from the server that you expected. Again, this goes back to only having one DHCP server. And then I love using curl. It'll even do TFTP, it turns out. So you can use curl to validate that the bootstrap and UNDI only files are where you expect them. And to be honest, if you got to this stage, you downloaded the bootstrap file through the Razor API, so you should know it's working at this point. Let's see. So let me go just look real quick at what I have set up here that we'll look at. So I'm just using VMware Workstation. You can use VirtualBox or KVM or anything really to do this testing. I have a Puppet Enterprise installed on one VM, and then I have the Razor installed on the other. And again, I just did the Razor install using the Razor Puppet module. I think I have yeah, so those are in there. There's Razor. It's got the Razor group, which has that module installed, or that module assigned to it somewhere. Classes. There we go, PE Razor. So if we go look here, let's see. This is, so I'm going to have a couple big walls of text, and hopefully they're kind of readable from where you got. So this is the Puppet Master, and I put the DHCP and TFTP server on the Puppet Master. You can, again, they don't have to be on the same server, it could be a different VM or what have you. I've got that bootstrap file and the undi only, which is the Pixie client. And so this is the bootstrap file. It really is a script that iPixie client runs. Not super legible, but the only thing the most important thing here to us is this chain boot line. So what this does is after the iPixie client's loaded the bootstrap file, it's going to execute this thing, and it'll use the chain boot to delegate off to Razor. So at that point, you can see it's hitting a API of Razor's. It's a Razor 4880. And then the /svc URL, when you see that, those are the URLs that are used in Razor for actually doing OS installation, as opposed to the API URL that we saw earlier, which is used for management of the Razor server. So here, it's basically posting in with some of its hardware data. You can see that the dollar variables there are iPixie client variables, so it's posting over its MAC address and its serial number and its asset tag. And then after that, Razor can say, okay, have I seen this guy before? Do I have a record for him? If so, then proceed appropriately. If not, it'll create a new entry and immediately tell this thing to download the microkernel image, which Razor has in its repos. And the microkernel image, so let's go back to there. So the microkernel image I said earlier is, I'm not sure what that is stripped down Linux. It's Fedora 19, it's about 150 megabytes. The main thing it does is it's going to run factor, and it's going to check in back to Razor with all of its facts. So at that point, now Razor will have, it'll know about the node already, and it'll have a bunch of fact information, which is your standard hardware fact information. So you have, amount of memory, processor count, whether it's a VM, a bunch of stuff like that. And So let's see. Let's go ahead and turn the server on, and we'll see if hopefully it will Pixie boot. So I'm just going to create a new virtual machine on the network.
I don't think we're seeing it.
It does not look like it. Thank you. Let's see here. Okay, let's see. What did I do? So maybe.
That'll be versus the
There we go. That's not going to work because then I can't see it. This, okay. All right, sorry about that. Okay, so we'll do a new VM. These are just the standard options. I didn't pick an ISO to install. pcamp 1 and start that up. So hopefully workstation will come back to me. Yeah, you can't see that really, but it's doing the Pixie boot process now. I think I have a slide here where I captured a screenshot. On the VMs, it goes pretty darn fast, so it's hard to really see what's happening. And let's see where that's with that. Oops, this is what I did before.
Windows P.
Windows what?
Windows P.
P is in Paul.
P. P.
P is in Paul.
Okay, so let's just go back to this thing. So here was the screenshot that I was trying to show you. At the top here, I'm afraid to press this slideshow anymore. Let's see here. There we go. So at the top here, you can kind of see maybe it's doing that initial Pixie request. You can see it gets an IP back and gateway and that sort of stuff. And then that's what I was saying. That's when it loads the iPixie client. And so then you see another section where the iPixie client is running. It also gets another DHCP, it requests a DHCP address, so you see some more DHCP information there. You can see where it's downloading the bootstrap file by iPix or by TFTP, and then at that point is when it's shoveled off to Razor. That's that chain boot line that we saw before. And then in this case, this was a new server, so that Razor didn't know about, so it tells it to boot the microkernel. So that's what it's doing. The last line there is loading the microkernel image. So at this point, hopefully we have a VM, except I paused it so it wasn't doing anything. So again, this one's at that same stage where it's loading the microkernel, and that doesn't take too long. I'm going to go ahead and start getting ready to deploy an OS on this thing. So what we have here, I'll show you a little bit of the Razor command line, is that Razor-help. So this is that Razor gem. It was mentioned earlier, you want to install this. And it takes, since this is PE, I've added a puppet bin to the path so that you can run this guy. And then this Razor API, you can specify if you want to override the location. This is an environment variable you can set if you want to override the API location. By default, it's going to look at the machine that you're on, so localhost port 8080. And so right now, I don't have it, so it's got a bunch of nouns. Let me go back here. So you can specify, and these are the things we have to set up in order to do an install. There's nodes, which as soon as something Pixie boots off of the server, that's when you've got a node. There's repos, which are essentially unpacked ISO images. So it can be your Linux ISO, Windows ISO, etc. There's tasks, which is the process, like how to install an OS. So you'll have like a Red Hat task or a Windows task. The Red Hat task will have a kickstart file. Windows will use an unattended XML, and blah, blah, blah. There's brokers, which is another little bit of kind of post-OS config that can happen on your nodes. Typically what you use that for is to install Puppet on the node after the OS has been installed. And finally, there's policy. I think I skipped tags maybe. Tags are basically rules to match the inventory. So the inventory that was recorded by factor, you can have matching rules for that. And then policies is what ties it all together. So to actually do an OS install, ultimately you need a policy, which will say, you know, for this repo, and this task, and this broker, and this tag, make it go. So the tags are what actually match nodes and sort of attach the policy to the node. So here so we don't have any repos, but you need a repo to do an install. And on PE, this is the location of the repo store, what they call the repo store. You can configure it in the config.yaml, but right now it's just got the microkernel image in it, which is that thing that we saw it download a bit ago. So I'm in this temp directory where I have some JSON files set up. Basically that Razor API or client is just a thin wrapper around the REST API, so it really just wants the JSON of the payload to post off to the Razor REST API. You can also specify, so let's do the repo here first. So in this case, the name is, in this case there's basically 3 parameters in there, the name, the URL, and the task. So you can also specify them from the command line, but I'm going to use the JSON files to create the repo and all the other things, just because that's how I have it set up. But so the ISO URL can be any URL. I think HTTP, FTP are supported. In this case, I'm using a file URL, so it's pulling it off the local appliance. And the task is Red Hat, so that's how to install. So if we create the repo, I think I have to do --JSON. That'll create the repo. And if I do Razor repos, I should have a repo now. I'm gonna make that bigger. So CentOS 6 minimal. And if I look in here, so, oh, it's not there. So I use the file URL, or the file ISO URL. So that means Razor's going to pull it off of the file system, and I suspect that I have permissions that Razor can't actually access. It's running as it's running as PE Razor in this setup. So I'm going to delete the repo. And we'll try again. So now we have this CentOS 6 directory, and this is all the files that were in the ISO. So Razor just unpacks them for you and puts them in there. And then those will be the source for actually doing the install. So we also need to have a broker. And this broker I have is just the Puppet PE broker, which is going to run the Puppet Enterprise install that bash script to install the Puppet agent. And that didn't work. Task is a required attribute. That's not right. Oh, I told it to install a repo, but it's not a repo. It's a broker. Okay, next thing we'll do is the tag. I have two here. So this is an example of what the tags look like. They've got a name and a rule, and the rule matches the node inventory, which I guess we should look at in a second. But if you know Lisp, then it will be really easy to use because it's kind of looks a lot like Lisp. So in this case, you have an and. We're saying that the processor count is 1, memory size is less than 4 gigs, and the is virtual fact is true, which means it's a VM. So this is going to match VMs with less than 4 gigs of RAM on the processor. Okay, so now I ran Razor nodes. This is that one node that Pixie booted, that VM that I started. You can see now it's got a tag, the tag is attached to it. So the tag did match this guy. He still doesn't have a policy, so it's just sitting there and running the microkernel. And so real quick, the facts, you can list with like this, I think. And it's just, you know what factory output looks like. So that's the stuff that's available to you. You've got, MAC addresses, NIC cards, things like that. So now, this server is just sitting at the microkernel, basically waiting for something to do. So we'll create a policy that should give it an OS to install. So the policy, like I said before, is tying together all the other things. It's got a repo, task, a broker. It's got some metadata as well, like a host name that's going to get applied to the server, password, and the list of tags that are used to do the matching. Policy. So we've created the policy. And there's Razor policies. I would have expected it to match the node here. That does say nodes 1. Okay, it just took a second to go through there. And so I think we missed kind of the money shot there when the microkernel, because the microkernel is checking in for the things that are supposed to do. And so what happened is when that matching happened, when it checked in, it was told to reboot and to do an install. So it's rebooted, and then we're doing the same Pixie boot that we normally do, but at this point, Razor knows what the node is, and it says, hey, I've got a policy that matches it, and it sends it through the OS installer of that guy. So that's going to run. It'll take a little while, but it's just using a Kickstart file. We'll look at those real quick. One of the cool things about Razor is that it's really pretty simple. So in other words, like all these tasks, they're just ERB files. You can change them on the fly. So you can do modifications, things like that. So let me find where those are. this is the Razor server main directory. There's a directory for tasks, a directory for brokers. If you go into the tasks, there's a Red Hat.task. And basically, you can see, if you're familiar with Red Hat installs, there's a Kickstar file and a post install. And it's an ERB file, so you can change things in there however you want. And they're really neat to test those changes. Like if you look in the log file for Razor, you'll see all the URLs that the install task requested. And then you can just curl those and get them back on the command line here. And then you can modify them if you needed to. So you can do things like change time zones, you can modify to install N2P servers, things like that. So that's still going. We'll just let that go. I kind of ran through that. That's that's the gist of it. So again, yeah, the tasks, like the default is Pacific time, which is terrible, so you need to go in and change it to Central time. And so just customize them to however you need the server to be. You can also create new tasks pretty easily. Like I said, there's a metadata file in there, and then there's the ERB templates, and that's it. Interesting commands. So one of the things you'll note is that how did you get that server to initially boot up? Because so now let's move to the scenario where we're not doing VMs and messing around with those. How did you get that server to initially boot up, to boot off of Razor? Did you have to go over there and press the button, or what have you? So like on my team, we use Dell servers. They have iDRAC out-of-bound controllers, so we use WS Man. This is orchestrated by a separate process. So we'll go just configure the switches so that the Pixie boot will work properly. Go turn the server on, and then it'll check in with Razor. So I noticed that they have now some IPMI commands built in, so you can also use IPMI to turn servers on and off if their LAN capability is enabled. And it looks like they now, I haven't used this, but it looks like they now have the ability to, once it's discovered with Razor, you can use Razor to reboot the server with IPMI. So that's pretty cool. Reinstall node if you want to. So once this thing is done, if we said, oh, I want to reinstall it, you can issue this thing. It'll reboot, get the microkernel again, and go through the whole process. So Razor microkernel extensions. This is a really cool new feature, newish feature. I would like to be using it, but we haven't started using it yet. There's basically, it lets you ship your own code over to the microkernel. So if you had some custom facts you wanted to populate, you could do that yourself. And then there's a blog link on here, a really neat page. A guy he built this microkernel based on, that installs the LLDP daemon. So that means that if you're in an environment where your switches have LLDP, which they probably do, then you can turn once it installs the microkernel, it'll automatically get all the switch connectivity information. So you can actually go into the Razor facts and see what switches the server is connected to. And like for my product, that would be really useful because then it would be easy to find the appropriate switches to go and configure. But for other, but we haven't gotten around to using that. We have our own current methods. We use Broadcom mostly, and those have LLDP built into them by default. So you don't have to do this step. A lot of NICs don't, in which case you have to have an OS running with the LLDP daemon. And I'm not going to go, we're running low on time, so I'm not going to go, I have some slides on installing Windows. You probably won't be surprised to learn that it's a bit of a pain in the butt, but it does work, and we use it all the time. The gist of it is you have to install this Windows 80K product on a Windows machine and run some PowerShell scripts, which is going to spit out a boot whim. And that boot whim, you end up copying into the repo directory. And it basically points to the right Razor server. Oh, okay, no, that's okay. I don't really, maybe I'll go through the rest of the slides then. Thank you very much. But so if you are actually installing Windows, some of the things that are required are you need a Samba share on your server because the Windows installer uses some SMB or CIFs to download a bunch of the files. So you gotta have that going. Another issue is Razor uses libarchive to unpack the ISOs, and it doesn't work with a lot of Windows ISOs particularly for some reason. So in that event, you'll just have to unpack the ISOs manually yourself. And so these are kind of reference things. If somebody did get into installing Windows, there's a few things you'll want to modify in the unattend file, like there's a license key in there, and there's an image name that you can set. And then right now it looks like the brokers don't install the Puppet agent for Windows, so I have a little command or a little piece that could go in your unattend file and install the Puppet agent. Just using because we already set up a Samba share previously for the install process. So you can add basically you can just tell the Windows installer to run a command and you can point it to that Samba share location. So if you plop your Puppet agent exe from Puppet Labs in that Samba share, then you can point the installer to just go install it off of there. And this has some command line options you can provide and specify the master server, agent cert name, and a few other things if you need to override those. So that's all I really had. Thank you. If there's any questions, I'd be happy to answer them. But if not, we'll just go on. What's that? That's a good question.
What was the question?
Did the server finish provisioning? So, yeah, thank you very much. So, we do have a server. So it's root and it's CentOS 1, so the 1 came from the node ID, and that was part of the little hostname template. So this is the server. It should have installed the Puppet agent too. So we can try to check in. No certificate found. And wait. Oh, I don't have the auto sign enabled. So we could accept the request, which hopefully is there. So we did have CentOS1.puppetcamp.com that did check in, or made the certificate request, and we can accept that. This is one of the things too that's nice about the DNS Mask is it'll do DNS. So just by the fact that the host name of that server was CentOS1, DNS Mask will register it, and now when it's acting as a DNS server, it'll tell you what the IP that it actually gave you for that host name is. So that's a nice thing. I accepted that. And that looks like that's working, so the Puppet agent is running. Except it did fail. Could not retrieve catalog from remote server. I had this problem the other day, and I think it may be that the time is actually out of whack here. 14. Because this is what I was saying about having Pacific time. It's also set to, I think it's using UTC, so it's off by a large number of hours. I think that's what's causing that to fail because the times don't match up on the SSL certs. So with my previous testing, I went in and changed the time zone, stuff like that. So yeah, so that's about it. So that sort of worked. And yeah, any other questions? Yes.
You mentioned NetApp storage integration.
I'm sorry, what's that?
You mentioned NetApp storage integration.
Yeah.
So how does that work?
Oh, there's a NetApp Puppet module and so this is an ASM product, obviously not Razor. And so we just use that NetApp module to provision volumes. I think we just support NFS right now. It's a bit of a pain. You have to go download their proprietary API along with the module. So the module itself isn't enough. Yes?
I know you said it supports ESXi, Linux, and Windows for Pixie. What about Solaris?
Solaris? I don't know. Anybody know? I have not installed Solaris. We can look in the tasks directory. I don't recall seeing that.
Solaris?
So I don't see Solaris. So these are all the tasks that kind of, you can't really see probably. But these are all the tasks that ship with Razor. You can write your own, yes. What's it? Oh, yes, that's the standard answer. You can write it yourself and submit it as a pull request.
I'll get started
Any other questions?
Done.
All right, thank you guys very much.